In this tutorial breakdown, I'm going to talk about how I created these modular steel beam supports and steel beams to use in Unreal Engine. Now, I've had this idea for a long time and I really like these supports and the way that you see the cutout holes in them, and I've never seen anything like that before. And I just thought they always look so cool. And I just kind of wanted to share with you on how I created these beam supports. Now, every single one of these that you see here is a modular piece. That means they will snap to each other if you duplicate them, and you can just snap them right on top or next to each other, and you can reuse them to create a larger environment. And same for these beam supports. If you take one, you can duplicate it and it will snap right to the top. So they're modular friendly, of course. Now, this idea came from an airport in Chicago. So of course, your first step on any project that you work on is create as much reference as you can of what you're going to create, what you're going to model. And if you watched any of the videos that I've done, then I stress this over and over again, pretty much in everything that I do. Never create in isolation. You always want to collect and create to photo reference. That's how you get the authenticity and the realism inside your models. Even if you're creating something more stylistic, you still want to reference something in the real world. So here's a master reference that I kind of composited all the photos into one. But of course, outside of this master reference, I have a lot more collected. This is just like one big image with most of the images on there. So here's what it looks like. A big master reference with just a bunch of little small images composited onto one. So that way I can just see in different angles, different type of light, and all the detail all in one single image. Now I'm only going to focus on the supports themselves and then the steel beams. So these are the only ones that I'm going to show you and do a breakdown on. But of course you can always add on top of the existing modular set to create walls, maybe different variation of the beams and so on. So after you've collected the photo reference and you know exactly what you're going to model, what you're going to create, the next step is to decide on the size, especially if you know ahead of time that this is going to be a modular set or a modular few pieces. Then you need to work with the size and decide what's the height, what's the width, and how are they going to snap together to create more of a modular set. So that comes from the Blockout. So my first step was to begin to determine the size overall of how big these pieces needed to be. So I've started off with the biggest piece first, which are these two steel beam supports. And I needed to determine, let me move these out of the way, and I needed to determine how big to make them. So that came from studying the photo reference. If you take a look at the photo reference here, in order to decide how big to start blocking them out, is when you look at any photo reference, you can usually see people next to them. And I highly recommend that you try to find certain types of architecture that you're going to create and see if you can find some kind of a dimension, a scale reference next to them. Could be a car, could be some other type of object that you know how big it would be. And of course, the best ones to find if there are people standing next to it. So that gives you an idea of how high you need to make them and how thick the rest of the pieces need to be of that object. So here is a good dimension reference of a person standing next to it. So you can see they're pretty tall. So what I usually do is just, if a person's standing next to it, I just estimate that that person is about 6 feet, close to that. So that makes it 180 centimeters in height. Again, this is not an exact science, just a good approximation, something to start from. And usually when I create a scale reference in Maya, the height of that character is 180 centimeters in height. So that's what I would usually do when I find a person next to it. That's my starting off point, 180 centimeters in height. So then if I take and double that amount, that gives me about 360. And then that may be a little bit more. So 360 is of course not a good value to use for modular pieces, 360 centimeters. So usually you want to round it up. And of course we have a little bit of a height left. So I round it up to about 400. And then when it comes to the dimensions in terms of the width and depth, well, I was going to play around with the values and see what felt right. So basically in the end, the photo reference kind of guided me on how big that I need to start blocking out dimensions wise in order to get it started. So in Maya, I have a scale reference that I use. It's a UE4 mannequin. And I have a video to show you how I exported that and brought it into Maya to use as my scale reference. But I also often use just a simple cube, and the cube height is 180 centimeters, about 6 feet of the character height. So before I start blocking things out in terms of the objects, I always have these inside the scene in order for me to judge scale and proportion better. Now, if you don't have this mannequin to use and you don't want to go through the steps, you just create a simple box. And I use both. A lot of people just don't want to go through the steps of getting this mannequin inside Maya. So you just create a box that's similar in size to this mannequin. And the size for this is going to be a simple cube with height at 180 and width 50 and depth 50. And that's a good value to start with. And then you can just snap it on top of the grid, move it off to the side. And that's going to be your human reference scale that you can always judge proportion next to. So once you have something like that, then you can begin to block out your objects. So I already determined, based on my photo reference, the height. So it's going to be 400 centimeters. So this first step is blocking things out. You're not modeling anything yet. It's basically going to be your template to see if this is the right size that you want to start to model to. So I created a cube and I set the height to 400. And width and depth, I've played around with this and I've came to a conclusion that 100 by 100 looked the most correct. So let me go ahead and snap this. And using these whole values is very important because the more rounded the values can be for your modular pieces, especially in height, as well if they're going to snap to each other in width, like a wall, or when we get to the beams, when the beams have to snap to each other, those values should be whole. So this is why I try to round to the nearest 100, or at the very least it would be 50s. So maybe 150 by 150 and so on. Now you can do anything in between, just as long as you keep it whole. But then if you vary those sizes, let's say you do like 110 by 110 or something like that, or maybe you do height at 390, it becomes a little bit more difficult for you to snap things on top of each other and side to side. So again, I usually stick with 50s or 100s. So by looking at this right here and just kind of referring back to my photo reference, I like the size of this square steel beam support. Now there are two that I created, and it was one was square and the other one was a bit of a more of a rectangular shape. But I started off with a square one, and then once I knew that the size was right, then all I did for the other one, for the triangle one, is just basically use the same cube. And then I just squished the corners of it. So I selected this face and then just scaled this in order to kind of see how they look together. Again, this is a rough blockout stage in order for you to determine the right sizes and proportion based on the character. So this is how I started, very rough, very basic, just kind of getting the sizes. And actually this early on, what I did was I exported these two cubes, one for the square, one for that little triangular shape, and brought it into Unreal Engine 5. And that allowed me to take a look in Unreal Engine with this basic shape. First, it allowed me to make a connection from Maya to UE4 and establish that static mesh to where I could re-import the mesh over and over again once I've made updates for it. But also, it allowed me to see if the scale worked. A lot of times when you're modeling things in Maya, it's one size, but then when you actually bring them into a game engine where you round around as a player, the size just seems off. It's either too small or too big. So early on, you really want us to get that connection going so you can actually see what it will look like to the player in game. And once I was happy in how it looked inside Unreal Engine 5, then I knew that this is going to be the size that I'm going to work with. And I went back to Maya, and now I have a template. A template to continue the blockout process of the rest of the elements within this steel beam support. Now, before I go too far into continue the blockout process and beginning to introduce more of that blackout detail of the cylindrical shape and so on, let me show you my grid settings. So by default in Maya, when you first begin, you're going to have a grid that's very small, and we need to adjust the overall grid and your scene to match to what you're going to create in actual real world dimensions. So if you go to display, grid options, Here are my current settings. My length and width, I changed it to 1000. This is the size of the overall grid, and it's just how big the grid appears inside your viewport. Then I changed the subdivision, which is by default set at 5, and I changed it to 1. I always change this to 1 with any new Maya install, and I never ever change it. It's always at 1. And then grid lines, this becomes your grid units per each grid. So if I take a look at my grid size right now, each gridding unit right now at the moment is 10 centimeters. If I change this number, let's say 5, each grid unit becomes 5 centimeters. So now my grid matches to Unreal Engine 5 1-to-1, and I'm able to create on the grid in Maya and exactly to the size of the grid in UE5. So if I change this to 10, this is what I usually work in Maya. Hit apply. Now my grid unit is 10 centimeters. So these are my default settings I use, and the only number I change after this might be the grid lines every so many units. Maybe I'll bring it down to 5. Maybe I'll go up to a higher amount if it's for bigger modular pieces. But usually I stay with 10 for most of the time. And once in a while, if I'm creating something huge and I need a bigger grid size to appear in the viewport, I may also change length and width to something higher, maybe 2000. But right now, 1000 for this project, that's what I stuck with. So next, I went into a more refined blackout stage. So I took these and I put them on their own layer and I locked them and turned them into a template. So that way I can see the outline because I like the size. I can use to create the rest of the more refined blackout within this more rough template. So I knew if I focus just on the first one and got the size of the cylinders right, and the thickness of each border for the bottom, for the top, as well as the size of the cutout for the middle, I would be able to transfer most of that stuff over to more of that triangle shape than the square. So I only need to figure out the sizes and the shapes once, and then they will be duplicated and propagated to the other one. So what I did was, and I'm going to show you the completed version first. So here are the more refined template blackout stage, where I simply just figured out more refined areas and more kind of detailed areas of how this overall template is going to come together. So again, this wasn't even a modeling stage. This was continuation of the blackout, just a more refined blackout. So here again, I figured out how many segments for each cylinder I would need to have. You can see everything's overlapping, everything's very, very messy. But I wasn't even focused on trying to optimize or clean anything up. I just tried to see where and how big some of the sections needed to be. So what I did was I just used the very rough blackout of just a cube and created a cylinder. And I knew it had to be 400 in height. And then I figured out, well, what would be the radius. So I just kind of started playing around with different values. Obviously not 5, maybe 10, maybe 15, maybe 12. And I was just trying to figure out the right thickness and position it right on the corner until I find the right value. And then when I liked it, I would just duplicate it to the other side and duplicate it again. And then I would create the top and the bottom, and I was trying to find the thickness for that. So then I would create a cube, and I knew it had to be 100 by 100. And then the height, I think I used 5. And again, these values I played around and tried to see what looked correct. And then once I liked the bottom portion, I'm like, okay, well, this is the size that I want. Then I would duplicate for the top. And then I would duplicate for the second portion. And again, I was looking at the references as I was doing this just to see where those important elements needed to be within this more refined blackout. And then once I had more refined shape, I then used the same cylinder on the other side, on the other one, on the triangular one. And that's what I ended up with. At the end, I did combine everything together because I wanted to first use it as my modeling template, because these were then going to be locked down to another layer. And then I was going to actually begin to model with more precision more care, because I knew where everything already had to be. And that's where I would optimize and then refine the shapes more and more, and then do the cutout holes. But even before I got to that modeling stage, I took these more refined blockouts back into UE5 and I re-imported them just to see what it looks like with all the important elements already there. And if I liked what it looked like at this point, then I knew I have it set. And all I have to do is just model with more precision, more care, and begin to include all the details that I wanted to include from the reference. I took these more refined templates and then I put them on their own layer, just like I did for the more rough ones in the beginning, and I locked them down. And I turned the visibility to a template, so that way I can see the wireframe. So I had a blueprint now to follow. So for the rest of the stage, I was more precise and more careful of how I was going to actually model this, because this is now the creation of the game ready model. And because I already had all the elements where I needed them to be, then I could just focus on the modeling. And here's what I ended up with. This is, let me deselect that light. This is the finished model that I used right on top of the template. Now let me actually zero out the transforms with the exception of the triangular one. So you can see they're pretty much identical. And I just basically took the cylinders and recreated everything. I didn't even use the template, the more refined blackout, as my modeling. I actually created everything from scratch. Created new cylinders, created new pieces of in the middle supports, as well as the bottom portion and the top and so on. And I was very careful, and I was just working on modeling this piece. Everything inside where the faces are not seen, everything has been deleted. You can see right here. There's no more overlapping going on, even though overlapping would be fine. But again, I just took very careful, more modeling centric approach to completing these two pieces. And I only had to do one of these right here for the cutout. I only had to do one of the cylinders. And I also had to just create one of these, and then it got duplicated all the way up to the top. So there's a lot of repeating elements. So it looks like it might have been more modeling than needed to be, but actually just I modeled one piece. I was happy with that. I duplicated and positioned it for the rest of them, and duplicated for the top. And then for this one, for this shape right here, all this is a cube. Let me create a cube. And let me just get it to this size, and I'll show you how I got this kind of a triangulated shape out of a cube. So my width was 100, my depth was 100, and height was 5. Then I took these two sides of the vert, so in the front, and I just scaled them in, like so. So that gave me the front. However, I wanted more refined angles on the side, like it was in the reference. So I just selected two of these edges right in the corner, and then I beveled them. Control B to bevel, and then I just adjusted the fraction. Maybe I think it was 0.3, but basically I played around with the values. And now I had the shape. And then I just fixed the rest of this. I made sure that it's on top of the ground plane, that it snapped. I was very careful about the snapping and making sure that this piece and everything about this was snapped to the grid, and so it's a modular piece in the end. So it still maintained the 400 height. So I made sure that I was snapping to bottom vertices and I was snapping to the grid. So if you hold down D, V, middle mouse click and drag, you can snap your pivot point on any object to a vert. I use that a lot. And then I can hold down X and then snap at my new pivot point on top of the grid. And then I just clean this up using multi-cut to get rid of that end gun. And I did the same thing at the bottom. So you can see it's a very simple procedure for the shape. And if I needed to get a little bit bigger just to match my template, I scaled that out a little bit. And here was my shape. And then once I had one made, I just simply duplicated for the rest of it. And of course I worked within the template, so the top can be right at the very top of 400 units in height. For the cutout holes, let me show you how I did that. I used booleans, of course, to get those holes cut out and to clean them up later. So I had a cube going created a cube to the size that I liked from my blacked out template, a more refined template. And I just got the size of this correct that I liked. So let me just, because I did use the Blockout more refined template, so let me just kind of size that up, because that's how I did it when I was working on this. So I kind of got the size of this correct and made it a little bit bigger so it's intersecting the cylinders slightly. And then I created a cylinder in order to position it right in the center. So the cylinder was only 16 sides. So I went to the input tab and I changed it to 60, lowered it, but because the default is 20. Then I got it big enough and I rotated the cylinder so it's facing forward, and then I just positioned it where it needed to be on this piece of geometry. Let me scale it bigger, and right about there. And I intersected it. Now, when you use booleans, the key is to make sure that your geometry is prepped, so you can use the booleans and it creates a more clean result. So you could just take this, position one piece of geometry overlapping the other, and then you select the first piece that you want to keep, hold shift, select the piece that you want to cut out, which should be your second selection. So the first selection should always be the one that you want to keep, and then the second one that's what's going to get cut out. Then you go to mesh, booleans. I'm going to make this into a floater menu and I use difference. However, when you don't prep the geometry that you want to keep ahead of time, then it just requires you a lot more fixing. So it can still work, but what I like to do when I use booleans and when I cut things out or any type of boolean operation is I prep the underlying shape first. I also want to make sure that this cylinder is snapped right to the center of my object, so I am more precise with this. So for let me move the cylinder. For this cube, I inserted additional edges right in the middle. So I used the model toolkit and multi-cut. I held down Control middle mouse click. Control middle mouse clicking inserts an edge right in the center between the other two edges. So I had a center that I could snap this cylinder to now, because I have a vert right there. So I selected this cylinder back and I held down V, middle mouse click and drag. And you can see how it just snapped at a pivot point right into the center of my cube. And now these lines right here line up. So when I select the cube first, then cylinder second, and I do my different separation now, the cutout doesn't create those weird kind of distortion in my geometry topology that I would have to fix. The result is a lot cleaner. And just to note, I am using operation difference and classification set to edge, because sometimes classification set to a different mode can give you some different results. And in this case, actually it doesn't change. So that was my settings for the different separation. So here, all I did was then clean this up by using the multi-cut. And I ended up with the result that you see right here. And I did it to both sides, front and back. And I deleted any faces that are not going to be seen by the player. So only the faces on the side. And then once you have one made, then of course I took this and duplicated all the way up for all sides. So again, to speed up your workflow and your process for modeling, just find those repeating elements, create one, and duplicate it. And it would probably even help if you create one, complete the modeling process, and then UV it, and then duplicate it. So that way you don't have to UV every single one of these again, especially once they're placed on for all different, I would have to UV every single one over and over again, giving myself more work. If I can just UV one and then duplicate it, then I would have the UV layout to deal with at the end, and they'll be already UV'd. And then I repeated the same thing for this one. And I even used the same one, I duplicated this one. So this triangular one was done exactly the same way, and I've reused a lot of the geometry to save some time. And in the end, because they're all separate pieces, I combined them into one. So let me go ahead and select them, just move them out of the way. And let me lock this down, or actually just remove the template. And here is the two final pieces all combined and as one single mesh. And then of course I exported them and tested them out in UE5 just to see how the light catches, how you can see right through the holes and so on. So, but I already knew that they were going to work based on my previous rough blackout imports. I just wanted to always see how they always look inside UE5 throughout this entire modeling and creation process. One more note on quick exports for testing from Maya into UE5 is when you export, make sure that you place your meshes at the world origin, and the pivot point should be on the bottom of the object exactly where you would want it to be in UE5. So the pivot point actually will be always placed into the world origin, no matter where the object is. So what I do is I place the object exactly where I want it to be at the world origin at 000, as well as my pivot point there. And when I export, it matches UE5 pivot point as well. And also I like to zero things out and freeze transformations at the world origin. So this is why I'm always able to move these meshes off to the side. And then whenever I need to re-export them back into UE5, I basically select it and I can come into the channel box and zero out my translations and rotations, and it will place them right in the world. And the way you do that is you first place the object at the world origin, at the 000 world space, at its pivot point, and then you freeze transformations. Modify, freeze transformations. So that zeroes all your transformations for translate, rotate, and put scale to 1, of course. And now if I move this object back anywhere in the world, work on another piece of a geometry or something like that, maybe another static mesh, and then whenever I need to maybe bring something back and update, I'm able to do so just by zeroing these out. Really save some time. And all of these meshes can be done this way. It just really does speed up a lot of this repetition for static meshes that you constantly have to export whenever you update. For these type of beams, for the curved 90-degree angle and for the straight beam with the cutout holes, here's what I did. I'm going to start with the straight one first. This was the easier one to do than the 90-degree arch. So very first thing is I started with establishing dimensions for the straight beam. I decided to go with 200 in width, so that way if I double them up, I have 400 in width. That would match the size or the height of the support beams. So if I ever needed to maybe use these straight beams and rotate them vertically going up, all I had to do was use 2 of them and that would match in height. But I also wanted to have a 200 in width or height to kind of vary the size if I needed to. So that worked out great, but that sizing was very important. So that way I could double up to get the height I needed. And then I began to establish some thickness to the straight beam and kind of get the basic blockout down to kind of get the right solidity of the shape of the volume. And of course, just like for the stands, this early on I exported into UE5 just to see what it would look like in comparison to the stands, as well as when you run around as the player. So I basically continued the export and re-import process throughout the entire modeling just to make sure that it's looking good. And once I was happy with the size, then I inserted a bunch of edges equal distance from each other using the connect tool. So basically I would select, actually let me go back to this one, to the straight one. I selected the edges in between. I went to model toolkit and I used connect. And I inserted a bunch of them. I believe I inserted 1, 2, 3, 4, 5, 6, 7, 8, 9 of them. And also one in the center. And for that one, I just used multi-cut and control middle mouse click. So what that gave me is ability for me to create a cylinder that I'd be able to snap right in the center, equal distance from each other, in order to create the cutouts. So that's why you can see how even they are. And there's equal distance away from each other. So this is what I ended up with. And then I created a cylinder. And the cylinder is 12-sided cylinder. So I kept it pretty low. And then I snapped the cylinder to the center of each of these intersections. So it's right in the center. And I duplicated, moved it over, and I snapped this one over here as well. And I continue to do this for total of 5 of the cylinders going across. And then I selected the beam first, the cylinder second, and I used the Boolean command, just like I did for the stands. And I used difference to cut out the hole. So not only did these segments allow me to snap a cylinder right in the center, it also made me have a cleaned up Boolean operation that these edges had already aligned to these verts. So I wouldn't have that kind of messy Boolean operation that usually happens when you Boolean and cut holes out. So then I continue to select the beam because that's what you want to keep, your first object, and then you select what you want to remove or cut out, which is your second object, and then you do difference again. And I repeated that for every single one, just continued and made difference operation. And then I went ahead and cleaned everything up by using the multi-cut and connected everything where there are n-gons. So let me go ahead and select it. So I'll just do just quickly one side. So I used multi-cut. Let me hit backspace to undo, just to repeat that. So I snapped to a corner, to a vertex, and then connected it up and did this for this one. And then for the corners right here, just connect it across. So now that's a quad. That's a quad. That's a triangle. So basically I fixed up the n-gons manually. So Maya or Unreal Engine 5 doesn't do it automatically. So that way it allowed me for a nice cleaner topology that I wanted to introduce rather than have it to do it automatically by the software. And this is what I ended up with. So again, this is a fairly lower poly version. I didn't introduce any bevels, although I could have. I wanted to keep it fairly low poly just like I did for the stands. And you see that when I exported it to test it in UE5, you can hardly tell the difference if because based on the third person approach, like you're not going to be super up close to them. You're a little further away from the camera, you see the character more, and they look pretty good. And this was for the straight beam. And now for the 90-degree arch beam. This one took a little longer to create based on the size and as well as based on the booleans and the fixing that I had to do. So to get started, I also wanted this beam to have 200 units in width in order to match this one right here. So if I were to, for example, create something where I put this beam on the bottom, like so, it would be able to snap on the bottom of the one below and line up perfectly. Have the same width across. Everything would be very modular and would have, like it would end on the corner as well. So it was very important for me to do this. And based on that, it took a little bit of prep work to get it the correct size. And also this piece snaps. If I move this all the way up, it has the same thickness. So when you put them two together to continue a longer beam support. So if you wanted to just continue duplicating and then maybe introduce it on the other end, you can. So everything had to line up perfectly. So these sizes that I created and used from the straight beam, I continued to use the same values for the 90-degree beam. Except to get the size, here's what I did. I introduced a template, a simple box, and I made it 200 by 200 because that's how big I wanted to have this 90-degree beam. 200 in width and also 200 in height. So this was my template that I started with. Actually, it was 200 in height, width, and depth. Depth doesn't really matter at this point because depth was controlled from this beam right here, how deep this beam goes across. So this was just a template for me to begin and to build in. So then I took this template, snapped my pivot point, then snapped the pivot point on the grid. And when I go to front view, let me get rid of the scale template. So within this template right here is what I wanted to have my arch to be created. So to create the arch itself, I used bridge, but I needed that curve to happen within this template. So I created my initial cube, which was 40 units in width. That was the depth, or that was the width for all the beams that I used. And the height doesn't really matter at this point, so I just put a 50 value down. And for the depth, it was 5. And then I positioned this on the very bottom, right below the grid line, like so. And then I duplicated this and put it on the other side. So I rotated it 90 degrees, and I snapped it to this corner. So I had the beginning and an end for geometry, and then if I combine those two, mesh combine, now I can select those faces, and I can bridge between them. So if you go to Mesh Tools, actually under Edit Mesh, or it's better yet, Modeling Toolkit, and then you go Bridge. And then if you switch Curve Type to Blend and Add Divisions, that gives you the curvature that you want, and it's going to happen within the template, right in here. So these right here were just a starting point, and they were outside the template. So in the end, when I was done creating the curvature using the bridge, I can go ahead and delete them. And I ended up with a 90-degree arch. And that's how I created this piece. So it was perfectly in 200 in width and 200 in height. I then continued and I added more thickness. So once I had this interior piece right here created, that's one you just saw me create, I then introduced another cut across and a cut on the bottom, and I extruded those faces to create more thickness so it would look like the beam. And the depth of this matches to what I had for the straight one. That's why you saw when you connect them up next to each other, they were perfect. So I made sure that whenever I inserted edges, they were right on the grid line in a specific amount of units, so it matches across different meshes. And I also, when I bridged, I included a lot more segments right across. So I ended up with a total of 16 faces right here. So it's a little bit more rounded, and also having all those edges inserted, if I go ahead and also do another multi-cut right in the center, that right there gave me the center vertex that I could create a cylinder and snap it to all the way across the arch, thus being able to do something very close that I did with the straight one, but now on a curved one. So if I introduce that cylinder back, I now have something to snap to that vertex, like so. And then if I just simply continue to duplicate, Control D, hold V, middle mouse click and drag, I can start snapping and go all the way up until I get something like this. So all the cylinders would align right to every other vertex. And then of course I just select what I want to keep, hold Shift, add the second item, which will be cut out, and repeat my Boolean operation difference. And after that, I would clean it up for every single one of the cutouts using multi-cut. Like so. And then I would continue for all the rest of the cutouts, front and back. Again, it took a little bit of time because I had to do so much of it. But in the end, this is what I ended up with. The result that I was going after. And then in Unreal Engine 5, when I imported all the pieces that I could use, I could perfectly align them and construct them together. So here's the straight one, here's another straight one, 200. Both of these together line up perfectly with the height of my supports, as well as the curvature of this one lines up with this one, which is another straight one, and I could just duplicate this one across. And if I wanted to curve back down, for example, I would just duplicate it, rotate it, and then align it better, and everything would snap together perfectly. In this case, I would just lower my grid point to 5 and make sure they are aligned together and snapped. So here I have a nicely created, far more interesting steel beams with cutouts that work together with the rest of the modular set. When it comes to UVs, I did UV every single one of these pieces, and my thought behind it, in order to texture and have a material on top, I decided to use tile and textures. So if I open up the UV editor and show you the UV layout, I used one texture to texture all of these. So if I select them all, they're going to be all within the same overlapping 0 to 1 space. Just based on the texture size, I decided to keep everything inside 0 to 1. and they look pretty good. If my texture resolution was not big enough, I would probably scale it and maybe go outside 0 to 1 space. That would also work. But through testing, I decided to keep everything inside 0 to 1. Just by based on my texture size, it worked pretty well as far as textile density goes. So again, this is going to be using one texture for all 4 pieces. So that repetition of texture didn't really matter to me, and Talon texture overall turned out pretty well, and I'll show you how I set that up in Substance. I also did create a second UV channel for every single one of these in order to have these meshes to possibly use with static lighting. Dynamic lighting in Unreal Engine 5, which is now Lumen, a brand new system for lighting in UE5, is fully dynamic. So that means it does not require any baked lights. So if you don't have any baked lights inside the scene, your meshes do not need a light map channel in order to bake shadow and light information onto a separate texture. However, for some, they may still want to use maybe a previous version of the engine, or they may still want to bake lights in UE5. You would need to have a light map channel. So if I show you just on a few pieces, so for example, this piece right here, everything is inside its own 0 to 1 space, as well as no pieces are overlapping. Same as here. For some of these pieces right here, they're all overlapping. So when it comes to light map UVs, everything needs to be in its own UV space, cannot overlap. So if I show you, for example, just for these pieces, because they are overlapping, this is a texture channel, and I can switch over to a different UV set, which I have a second UV channel, light maps, and everything is unwrapped uniquely. Same thing for this piece right here as well. And even for these right here, I do have them unwrapped and maximizing 0 to 1 space much better. So if I go to UV sets, here's my light map channel, and here's my texturing channel. And the reason these texture UVs are so small is because they match in density, in textile density, to these pieces right here. So even though it looks like I could have maximized them as much as I could, actually no, because if I look at the textile density for each of these UV shells, they're all the same. So I kept them very proportionate to each other. So let me go ahead and switch back. So again, you don't need a light map channel unless you're going to bake your lights, but I wanted to have that option on these meshes. For the texture, I used Substance Painter, and I kept it extremely simple. I knew I wanted to use a tiling material, so this is what my end result was. Very simple tiling texture created entirely from one of the smart materials, and I adjusted the properties, the default ones, in order to get the color I wanted. I wanted to keep it white color with some metallic properties showing through. So basically painted steel with a bit of dirt and chipped away paint. So if I zoom in a little bit, you can see it has a bit of a dirt and grime and chipped away paint going through to see the steel underneath. The way I did this is you don't even have to bring in any meshes to texture, because I didn't want to uniquely texture any of it. I just wanted to have one flat texture and then have all those UVs do the work that you saw just based on the style and texture. So if you go to File, Open Sample, and choose Tile and Material, this gives you a starting point of a tile and texture to use. Now it comes through with a bunch of settings already, bunch of layers. So just go ahead and select them all and delete them. So now you have a flat plane to work with. And the material I used was a smart material, and it was steel painted chipped. I believe it was this one right here. Yep, steel painted chipped. Yep. So that one I had and left click, hold and drag right onto the mesh and apply it. So this was a starting point. Then if you open up the folder, then you can go through and adjust different properties, different parameters for this material. So you have metal controls. You can edit it inside the properties for that layer. You have the paint. You can adjust the paint color. Change that to whatever you want. So you go layer by layer and adjust whatever properties you need in order to get the result that you're after. Now, when it comes to selecting the material in here, you can just click and drag any of the materials right on top of your mesh. It will insert a new folder on top, and you can see which one you may want to keep. So I went through and I just kind of tested which one do I want. And most of these are tileable. So basically you find the one that you like, keep it, and then go ahead and adjust it. Now, for example, this one right here on this tiled plane, you can see that it is not tiling. So for the steel rust surface, that's probably not a good one to use. So this tile material sample that you can use does show you if the material will tile. And you can adjust some of the tiling parameters in the material, so you'd have to go through the layers and do so. So I ended up with this result, and then when I liked the result of this, I went ahead and exported it as my final texture. Went to File, Export Textures, and I used the UE4 preset. And I exported the color, metallic, which is a packed texture that gives you metallic, roughness, and ambient occlusion, all in one texture. So it's a packed texture. And then the normal map. And I did not create an emissive. I did not have any emissive properties on it. And my output was 2048 by 2048. And went ahead and exported it. So they gave me the 3 textures that I would bring into UE5. And finally, inside UE5, I already imported all the textures. So let me show you. So if I go into the content drawer or the content browser, go to textures. Here are my textures. Here is the painted metal. Then I have a normal map. And then I have the packed texture. So this packed texture, if I go ahead and take a look at each channel, so I have the red channel, which is your ambient occlusion. Then you have your green channel, which is your roughness. And then you have the blue channel, which is your metallic. And the way I remember which channel is which, in order for you to hook it up correctly, is ARM. A-R-M. A is your ambient occlusion, which is the red. R is your roughness, which is the green channel. And M is metallic, which is your blue channel. So it's a little acronym that I use to remember. And one thing for this particular texture, I went ahead and disabled sRGB. This is super important before you set up the material with it. So this was enabled and I went ahead and turned it off. And then of course save after you disable it. So now let me open up a material and show you the setup. So the material is extremely simple. I added a few controls for it. By default, all I had was a color map hooked up. Here's my packed texture. And here are all the channels. Here's the red channel, which is ambient occlusion. It's already hooked up right here. Then I have the green channel, which is hooked up to roughness, and the blue channel, which is hooked up to metallic. And then I had a normal map, which was originally just hooked up with RGB going straight to the normal. However, I wanted to have a bit of control, not a lot, just slight, to make adjustments through a material instance. So the one thing I wanted to add was ability to adjust color and change it for any beam I wanted. So by default, or usually what you do is you have constant 3 vector converted to a parameter. So if you hold down 3 and left click, it creates a constant 3 vector, and then you right click on it and you convert to a parameter, which will then show up inside the material instance as a way to edit. And then you give it a name, and I already give it a name right here. And then you can change the color, the default value right here in the left hand detail panel. And you usually connect the texture sampled, your texture color, and the color changer, the constant 3 vector, with a multiply. But I wanted to also have ability to control where the scratches, so the scratches do not receive any color. And I had to do this through a lerp where my color and my constant 3 vector are connected to A and B. And then through an alpha, I have a contrast control that inverts the metallic texture. So it will not change anything while I apply the color to it. And I connected it like so. So I took the metallic, the blue channel, and I rerouted like so. So that gives me control to adjust where the scratches are and how much they appear on the mesh or on the texture. And then I also have ability to adjust scale for the entire color texture, and it's connected to everything because I needed to adjust them all at once. So here's what it looks like. This is a texture coordinate. It's being multiplied with a constant 1 vector, which is my texture scale, and default value is 1. And it's connected to all the UV inputs for every texture I have, which is only 3 textures. And then I also have a normal map intensity because I wanted to maybe add a bit more intensity for the normal map. So with all this set up, let me go ahead and save. And I already applied it to the meshes. So the material instance is already applied down here. And the way you create a material instance is you simply right click on the material and you go create material instance. And here's my material instance showing up. So it's already applied on every single mesh. I just left click and drag to apply it. And then to change the values, you have to open up the material instance. And let me make it a little smaller. And just simply look at your mesh. And then you have values to turn on and off. So if I just go ahead and disable these really quick, here's what I had. And now I can adjust my color to whatever color I may want. I have ability to adjust scale. So let's say default was 1. And if I wanted to maybe emphasize it so it's not so small, I can lower it down. Then I have power contrast, which will emphasize the contrast for where the steel appears through the paint. So 1 is the default. So if I wanted to just kind of push that forward, maybe 3. And then I also have normal map intensity. So by default it's 1. And I just have to maybe zoom a little closer. So if I go to 3, those bumps right here show up a little bit more. So if I push it higher, you can see them pop out. And if I wanted to invert them, so I wanted to push them in, I would just go in the negative value and push them in. That's a little too much, but just wanted to emphasize it so you can see it. So now you have some control over your texture and how it appears in your meshes, and you can adjust it, and you can create different material instances with different colors. So again, I wanted to keep the texturing and the material process simple, just so I have some variation. So the main takeaways from this project I learned is, first, I should have added a little bit more detail to these steel beams and the supports, especially for the little cutout areas, and maybe even bevels. The silhouette of them looked pretty good. So if I press 7 just to check out the silhouette, I do have a light in here, so let me delete it really quick. So the silhouette of this is very nice. I always like the design of these beams and the way they create the cutouts and how much of negative and positive space that you see. But when it comes to the detail, if you get up close to them, they do lack that geometry detail. So I would have added maybe a little bit more of a bevel around all the corners and maybe even introduce a higher amount of cylinder to cut out. So it's a little more smoother. And the other thing for as far as texturing goes, I would introduce a lot more variation into the beams themselves. So far away, they still look like they don't have any color applied. But when you get up close, the amount of variation is very subtle. So if you add a different color through a material instance, it does pop out a little bit more. So I do have that option. But initially inside Substance, I would have added a bit more variation to the beams and the supports themselves, so it doesn't look so bland. So that's one thing I would add, and probably will in the future, as it's very easy to update that by going and reloading the file and just reintroducing some variation within the texture. So I hope you enjoyed this breakdown, picked up a few tips, and I'll see you in the next one.